All right, today we are diving into one of the biggest challenges in generative AI. How do we make it truly trustworthy for the enterprise? We're going to talk about how to ground these incredibly powerful models in factual real-time data. Basically, we're going to transform them from these unpredictable ghosts into the reliable machines your business can actually depend on.
And that quote really sets the stakes, doesn't it? In these super high consequence environments, think finance, healthcare, legal. An AI that just makes things up isn't just unhelpful, it's dangerous. There's absolutely zero room for error when the integrity of your data is on the line.
So let's be clear about what we're up against. A hallucination is when a large language model, an LLM, confidently spits out fiction as if it's fact. It's not pulling from its training data, it's literally inventing an answer. Now, for a chatbot helping with homework, that might be, a minor annoyance. But for a critical enterprise application, it's a total non-starter.
This really is the million-dollar question, isn't it? We've got this amazing AI brain. It can reason, it can generate text, but it's totally disconnected from the proprietary, up-to-the-minute data that your business actually runs on. So how do we build that bridge and do it securely and effectively?
Okay, here's the game plan for this explainer. We've talked about the problem. Next up, we'll break down the solution. It's called RAG. Then we'll see how to build it on Google Cloud, look at the super important data store choices, check out an advanced pattern called GraphRAG, and then we'll wrap it all up.
So, how do we fix this whole hallucination thing? Well, the main technique we use is called Retrieval-Augmented Generation, or RAG for short. This is the secret sauce, the mechanism we're going to use to finally ground that ghost in the machine and connect it back to reality. Let's really dig into what this means. Instead of just relying on the model's static, pre-trained memory, which can get outdated fast, RAG basically gives the model an open book test. For every single question you ask it, it goes out to a library of your enterprise data, finds the most relevant stuff, and then sticks it right into the prompt. This grounds the model in your reality, and you get to skip all that constant, expensive retraining.
And here's the flow. It's so simple, but it's incredibly powerful. Just 4 steps. 1. A user asks a question. 2. The system instantly retrieves relevant, factual documents from your private knowledge base. 3. It then augments or enhances the original question with this new context and feeds the whole thing to the LLM. 4. The LLM generates an answer that is based on the evidence you just gave it. It completely transforms a potential wild guess into a solid, fact-based response.
Okay, enough theory. Let's get practical and see how this actually gets built on Google Cloud. We're going to take a kind of X-ray view of the architecture and look at the specific services that make it all happen.
So, a typical RAG app on GCP has about 4 main layers. You've got your front-end application, often running as a serverless container on Cloud Run, or maybe GKE if you've got a more complex setup. The brain of the operation is Google's Gemini enterprise model, and it's all running on Vertex AI, which is Google's unified ML platform that orchestrates the entire workflow. Data gets into the system through scalable services like cloud storage or PubSub for streaming. And then, at the very foundation, you have the vector data store. This is crucial. It's the long-term memory for your application, where all your factual data gets converted into these numerical representations, called vector embeddings, that capture its true meaning for super fast and relevant search.
And that brings us to what is maybe the most critical architectural decision you're going to make when you build a RAG system: choosing the right vector data store. Seriously, this is the foundation. Everything else is built on top of it.
And I've got to tell you, there is no single right answer here. The best choice is driven entirely by what you're trying to do. Are you dealing with massive scale? Is your data just unstructured text, or is it mixed with structured data? Do you want a fully managed service, or do you need maximum customization? These are the questions that will guide your decision.
Now, this table is awesome because it lays out the mean patterns on GCP. Let's walk through it. For pure massive scale semantic search, think large-scale personalization, searching millions of documents. Vertex AI Vector Search is your go-to. It's purpose-built for that high-performance job. Now, what if your AI needs to access operational data like customer order histories? Then using AlloyDB or Cloud SQL is a fantastic choice because you can store your vector embeddings right alongside your existing transactional data. And finally, for those teams that need maximum control, the ones who want to use the open source ecosystem with tools like Ray and LangChain, well, building on GKE and Cloud SQL gives you that ultimate flexibility.
But what if just finding relevant documents isn't enough? What if the real gold is hidden in the connections between your data points? This is where we go a level deeper, with a really cool advanced technique called GraphRAG.
So first things first, let's get our heads around a knowledge graph. Unlike a regular database with tables, a knowledge graph stores info as a network. You have nodes, which represent things like people, companies, products, and you have edges, which represent the complex relationships between them.
Okay, so here's the key. GraphRAG isn't an either-or thing. It combines the power of semantic vector search with the ability to walk through all those rich relationships in a knowledge graph. This lets the AI uncover context and insights that would be totally invisible in a simple document search.
So, check out the flow here. A user asks a question. The system first does a vector search to find the best starting points, the nodes, inside the knowledge graph. From there, it actually traverses the graph following all the connections to discover related information. All of this rich, interconnected context is then used to augment the prompt, which leads to a way more detailed and insightful answer. This is a total game changer for complex fields like clinical research or financial analysis.
And this makes the difference crystal clear. Standard RAG is great at finding the right needles in a haystack. GraphRAG finds the needles and gives you the entire web of thread connecting them all together, so you get the full picture.
So, what's the perfect foundation for this advanced setup on GCP? Spanner Graph. Its power comes from being a unified data store. It can store both the knowledge graph structures and the vector embeddings all in one place. That simplifies your operations like you wouldn't believe. And on top of that, you get all the classic benefits of Spanner: global consistency, massive scalability, and industry-leading reliability.
All right, let's pull all of that together and quickly recap the key takeaways before we look at what's coming up next.
First off, remember this. RAG is the fundamental technique for making Gen AI enterprise ready. When it comes to choosing your data store, this is your cheat sheet. For huge semantic search, it's Vertex AI Vector Search. To mix vectors with your existing operational data, go with AlloyDB or Cloud SQL. For maximum control and open source love, choose GKE. And finally, for your most complex, interconnected data, GraphRAG with Spanner Graph is the answer.
At the end of the day, this is the core principle. It doesn't matter how sophisticated your AI model is, if its connection to reality, to your data, is weak. A solid, well-architected grounding foundation is what separates a cool proof of concept from a real, production-ready system. So we've designed the brain and the memory. We have grounded the ghost. But, building is only half the battle. How do you actually deploy, monitor, and manage this thing reliably at scale?
And that is exactly what we're going to cover in our next explainer. We're going to dive deep into the world of MLOps for RAG applications, how to build robust CI/CD pipelines, how to monitor for performance and data drift, and how to make sure your system stays healthy and reliable in production.
Hey, thanks so much for joining us. Make sure you subscribe so you don't miss our next deep dive. Hit that bell and stay grounded.